guys, so this is the tutorial on how the lab worked. We were pulling everything at a constant velocity, so the velocity was constant. This is important because it helps us with a couple of our values. So let's say we're moving constant velocity to the right. Okay, and let's make the force applied, which would be the way that I'm moving. Let's say that the force applied is 4 newtons. All right. Well, if velocity is constant, I know that my force friction has to be what? Equal, right? So this is also 4 newtons all the time. If velocity is constant, the forces have to be balanced. Okay. You also know, this is very, very important here, my downward force is called force gravity, also known as weight. The upward force is force normal. For a flat surface, it's going to oppose gravity. Okay? How do I find my force gravitational? Well, this is weight. Look here. That's the equation for it. So equals mass times gravity. Always start with the bottom one first if you can. My mass is 8 kilograms. My gravity on Earth is, we're going to use today, G is going to be 10 meters per second squared. 10, so that's 80 newtons, right? Newtons is mass, or weight. Okay, so I know that if I'm on a flat surface, I'm not accelerating up or down. I know this because there's no acceleration. There is no acceleration. The system is in equilibrium. What's the net force of a system in equilibrium? 0. So I have to have 80 minus 80. Right? That's how I get a net force of 0. Okay. So done with that. Now the last part. Usually they're going to ask for the coefficient of friction. This is kind of a bonus for me if you can do this. Okay, so coefficient of friction is right here. Force friction divided by force normal. Okay, so that's going to be force friction was 4 newtons. And my force normal is 80 newtons. And notice what happens to my units here. What happens to my units? What happens to my units? The newtons cancel out with newtons. I get 4 divided by 80. 0.05. No unit for coefficient of friction. Okay. All right, so let's review what I did. I started out with I told you that this was 8 kilograms. Actually, let's change it up now. Let's say it's 4 kilograms. We're going to change up the entire problem so you can see me do it one more time. 4 kilograms. Velocity is constant again. So what's that mean about force net? If velocity is constant, I know the force net is 0. So whatever my force applied is, I know my force friction has to be the same. Okay. Which one do I know how to fill in right away? The top, bottom, left, or right? I know how to fill in the bottom one. This is force gravity, right? Top one has to be force normal. Force gravity is just mass times gravity, which is 4 times 10. So I get 40 newtons, which means the top one also has to be 40 newtons. If I told you that my force applied was 10, that means what does my force friction have to be? Well, I told you that my system has a net force of 0, so this also has to be 10. Okay, last but not least, how do I figure out my coefficient of friction? It's this equation right here. Force friction over force normal. Okay, and that's going to be, sorry, it's kind of nasty. Okay, so that's force friction is 10 divided by force normal 40. Put that in the calculator. 0.25. And newtons, but it doesn't matter because what happens to my units with coefficient of friction? They cancel out, right? Okay, so again, we start out with the bottom one, try to figure out the force gravitational or the weight, right? And that's really easy to figure out because that's just the equation, mass times gravity. As soon as you know this one, you automatically know the top one. These you can assume right away. And if you know your velocity is constant, that means the net forces have to equal 0 because there's no acceleration in a system in equilibrium.